All right, students, we are going to get started on a new section here called Algebraic Expressions, and we're going to jump right into this, where we're going to start by writing down that expressions are mathematical formula that don't contain an equal sign or an inequality sign. I'm going to continue on here, but if you'd like to pause the video at this point, you could do so, and you could play right after you're done. So, the expressions, algebraic expressions, are really rules. These are rules that we have to follow. So a quick example of a rule that we have to follow, if you think about it, is I could say no one is allowed to run in the hallway, right? And if you were to say, well, what about one particular student? Like, let's say I have a student named Haruki and he wants to run in the hallway. Well, does he count? And we could say that yes, because he's part of the no one, then this counts, right? So for example, no one, or let's just make it simpler here, can chew gum. And let's say I have a student named Ryan, and because Ryan does fall under one, so no one, even him, can chew gum, right? So in other words, no Ryan can chew gum. So when I say no one can run in the hallway or no one can chew gum, that means no Haruki can run in the hallway or no Ryan can chew gum. This is generally what algebra is. It's a mathematical way of writing these rules where we could better explain what students or people are allowed or not allowed to do. So the idea is we use this thing called variables. And so we're going to write down some key terms here. And before we get started with working with this, because these are some terms that we'll say quite a few times. And so the key terms, we start with variable. And that is a letter or symbol used to represent something. Now, this something can be replaced. So sometimes not all numbers are set. Sometimes we want to play around with the scenario and I want to say, well, what if I bought 2 apples? What about 3 apples? What about 4 apples? So sometimes I could use a variable to express that. The variable is that letter. Now, a term is an amount of a variable now I'm going to add something here, or a constant. So I'm going to underline variable and constant here. So that leads us to the last bit, which is, what is a constant? And that is the opposite of a variable. So it is a number that cannot change, or a number that will always remain the same. All right, so these are some of the key things that we are going to keep in mind as we get started with this concept. All right, so we're going to do a couple of examples here just to identify how many terms and how many variables and constants there are, okay? So let's say I have 3x plus 4y plus 2. Okay, so I'm going to identify where the variables are, what the terms are, and where the constants are. Now these three right here are all terms because they're an amount of something, a variable or a constant. I have 3 of x, I have 4 of y, and I have 2 that will always be a 2. Now on the other hand, I have these. Those are what we would consider as variable. How do I know that? Because I have the letter, and that letter can be replaced with a number. So if I want like 3 of x, then I'll get a total of 9. All right, if I want 2 of y, then I'll get a total of 8. And this right here is a constant. So you could see how it's kind of like in a class I have boys and girls. So the class is like the terms, right? Students, how many students there are. Both boys and girls are students. But then you have the variable, which is the, let's say that's the number of boys, and constant, which is the number of girls, right? So they both add up to become the terms. That's a general understanding of what we are going to do here. Now, the next segment is where we will talk about adding and subtracting variables. Oops. All right. So before we jump into this, there is one more keyword. We're going to add this phrase, and I'm going to put quotes, like terms. So like terms are terms that have the same variable. So an example here would be, let's say I have something that's 3x and I have 2x. They're both x's, so they both work. Another example, now let's do something a little bit more wild. Negative 4y and 0.23y and 1 over 4y. You can see how they're all the letter y's. They all have the same variable, so they are considered like terms. Now, why do we need to know these like terms? Because what you're going to focus on in the beginning section here is that you can add or subtract like terms. Now, when you are adding or subtracting, you are going to use any rules that you have learned previously on integers. So don't get thrown off by those. Think of these as units, right? Like sometimes you can think of the x as like apples and the y as oranges. You kind of know how to go about questions like that. So that's how I want you to imagine this concept. Let's get started with an example here though. Let's say I have 4x plus 3x. So if I were to add these, I would take a look at the numbers. I would ignore the letters for now, as long as the letters are the same. So like apples and apples. So then I could have 7x. Now, what if I had a fraction, right? And this I'm going to add a negative as well. So 1/2 y plus negative 1/4 y. So if I take a look at this, I see that the y's are generally the same. So again, I'm going to treat it like I have half of an apple and I'm adding a negative a quarter of an apple, let's say. Right, so you could see how you would totally just kind of let the units aside for a second, right? You wouldn't focus on them too much. So don't worry about the y's, but then instead I'm gonna treat it as if it's 1/2 plus negative 1/4. And so if I have that, or let's see, I'll do it as I normally would. I'll convert this into, let's say, the same common denominator. So 2/4y plus negative 1/4y. And I should be left with positive 1/4y. And that is my answer. So you see how I'm dealing with these numbers as if they're just normal numbers. Okay, now if you have a few variables, group the like terms before adding or subtracting. All right, so what do we mean by this? Let's do this example where I have 2x plus 4y minus 6x plus negative 0.5y. So now you can see that it's starting to look a little bit more complex, but if you do this step by step, one thing at a time, you should be able to resolve this. I'm going to use a different color just to kind of be able to see the differences here. So what I usually like to do is I like grouping the same numbers or the same variables first. So let's say I start with a 2x. Now I'm going to sort this all out. So what I'm going to do when I sort it out is I'm going to tell myself, all right, I got the 2x in there. So I'm going to scratch that. That way I don't like redo it. And I'm going to look through the entire equation to see if there's another x. I see here that there is a negative 6x. And so what I'm going to do is I'm going to cross that off. I'm going to write that down into my equation. So if there's a minus or plus, I would say like just keep it in front of that term when you're putting it in. So then I'm left with the y's. So I'm going to do the plus 4y. Again, the plus just follows that. And I have the plus negative 0.5. So plus negative 0.5y. And now I should be able to answer these by kind of going one variable at a time. So in this case, I'm going to start by combining these two. I'm going to have negative 2x minus 6x, which makes it negative 4x, plus, and then I'll just write down the 4y plus negative 0.5y. You see how I'm not going to bite off too much at once because sometimes it's hard to keep track. So then I'm done with the x's. I can't combine the x and the y, so I'm going to rewrite this. And now I'm going to do this. So 4y minus 0.5, right? Because they're opposing teams. So I'm going to get plus, and I'm going to be left with 3.5y. Now I'm going to have to leave my answer like this. So I know it's sometimes unsatisfying to leave it as a little expression because you're like, well, you know, don't I have to have one answer? In these cases, unfortunately, you're just figuring out the rules and you're trying to simplify them. So you can't quite do that, right? We have to leave the x's and the y's by themselves. There are some other key points that you probably should keep in mind. If there's only one variable, or if there's only a variable and no number in front of it, which we call a coefficient. So if there is only one variable, it has a value of 1. And I don't usually write my ones like that, but I'm trying to do that so that we don't mistake it for an I or something like that. All right, so example, if I have the letter T, then that really equals 1T. And that's it, okay? So the reason why we would want to keep that in mind is because if then, let's say I have letter T plus T, so it's going to be really 1T plus 1T, and that equals Tutti Frutti, 2 T's. And that's my answer there. Subtraction, we follow the same rules, which is why I put it under this pile right here. And so if you do have some integers, then you're going to have to keep in mind those integer rules as well. So here is generally what your notes are for this section. So see you in the next one.